I decided to include this section on deep neural networks, so you don't ask something like, when are you going to teach us something cool like deep neural networks? Well, you already know how to use them. It's just a neural network that has many connections, many hidden layers, and so on. I'm also going to teach you a way to go from the 5 features we've been using to 400 features. But as you can see from how long this video is, it won't be rocket science. We'll just use the pixels themselves as features. So it won't really be a deep dive this time. We'll only go skin deep. Get it? Deep dive, skin deep, because deep neural... No. Gonna code, debug, and have fun. Coding with Radu, coding with Radu. Gonna prototype and design. Coding with Radu, coding with Radu. Let's code now. Inside of feature functions, I'm going to comment out everything here, really. And we will implement a different kind of code structure here. It will break what we have previously, so keep a backup of that if you want to compare. But we won't do many changes today, so you can also revert if you pay attention. Now, what we do here is we open up an object with the name pixel array, so this will have all the features coming from one function call. And the function is going to be called on paths, but then it's going to return all the pixels from our getPixels function, which we call on the paths. But I'm also going to specify a size, because I don't want to have 400 times 400 pixels. That's going to be a lot of pixels, and they are not necessary. We can figure out what the drawing is even from a small drawing, and it's going to be more efficient. So in my case here, I'm going to use a small 20 by 20 canvas. Now let's close these, and this is going to be a feature vector with 400 dimensions. Now we need to change some things in the code to work with this new structure. And we're going to go to node feature extractor JS and comment out this line here. And instead write this new one that only takes out the values of calling the first and only function that we get from the feature functions in use. So we call this one here directly on the paths and get the values, assign them to the point. Now, this feature names at the moment would just say pixel array here, and that's not good. They need to be many of them, 400 of them. So what we do here is comment out this line, and I'm going to write this new one where we create an array the same size as the first sample's point length, and we fill it with zeros. Or anything you want, really. We can fill it with an empty string like this. It just needs to have 400 items for the code to work. Now, for the web to work, we also have to do this for the real-time calculation of the features there instead of this mapping here. And here we can just take the first function and call it on the paths, like so. Now this should work. If we open now the terminal, we can extract these new features. Let's go to the node folder and then extract these new features. And let's have a quick look what they are. Inside data, dataset. And now let's, for example, open these CSVs. They are easier to read. You can see at the top the feature names. They are those empty strings separated by commas, and there are many of them, 400 of them. And last thing is still the label. And then here there are pixel values, visible pixels here, and some pixels may not be fully visible because of this anti-aliasing, but some pixels are completely invisible. And this is the whole very long feature vector for each individual sample. So can this work? Well, if I'm going to optimize now with Python, it seems it does. And we're now at 70, almost 75%. Wow. Let's take a look in the web page. And we now have this beast here with all these connections here from each individual pixel, all 400 pixels of the small 20 by 20 size image. And this is the new accuracy. This is the new matrix here, and it looks really, really good, doesn't it? This we already said we don't look at anymore with these high number of dimensions there. And if we try to make a new input here, it seems to work. And I made these nodes here very, very small in the visualizer if they exceed a certain value. Now, if you want to get an even nicer visualizer here that somehow modifies also the weights based on the activation of these bottom neurons here, then you could go in the visualizer and go to draw level. And here we're drawing these weights between the inputs and the outputs. So they are the lines, and we set here the value, the RGBA of the weight value, but we can multiply this by the inputs of I. And this is going to make that connection disappear if that pixel is off, or be there present if the pixel is on. Because of that anti-aliasing, it could be also some transparent value. So let's save this, refresh, and now everything is off here. But if we start drawing something, we start to see there those connections appearing. And I think it's interesting. It makes this a much more dynamic system. This is not a pencil. Oh, come on. Maybe if we give it some more detail, like... Okay, now it's a fish. Great, but this is not yet a deep neural network because it just has this one hidden layer. Let's go deeper. We're going to go to our Python script. Let's put 100 nodes on this one hidden layer for now, and then we try more later. So let's optimize again. 82% accuracy. We broke another barrier there at 80%. Let's see how this one looks like. And this is it. Wow, look at that. Now this system starts to become slow because of this visualization here, but also because the model becomes more complex and there are more calculations. I think we can try with 2 hidden layers so that we do get some deep network, even though deep means a lot of them, but you get the idea. Let's add 100 more. 83%. Not a very, very big improvement, but it's still an improvement. Now let's see how it looks like. So now we have this. And if we draw something, a lot of crazy stuff happening there. And it is a house. It seems to be quite reliable. Like after it's a house, it's a house here. Well, let's see our confusion matrix one more time. And yeah, this looks really good. And let's have a look also at the classifications. Very few of them are not blue right now. Now, people have different views here. Some like the small models with relatively few features and consider big models like what we just built as a waste of resources. But others think they're worth it because you can teach them pretty much anything without the pain of tailoring features one by one. The problem is, it's really hard to explain why the system works a certain way if the model is so big. Hope you liked the course. Let me know if you want to see more. Like, I didn't teach you anything about clustering yet, and it's an important part of machine learning. Or we could try to identify the person who is doing the drawing instead of what is being drawn. Maybe we can make a really sophisticated authentication system like that. What do you think? Go in the poll in the description and vote your favorite. See you guys.